Yeah, we are looking at question 4. Evaluate the integral of this function 2x plus 1 from 0 to 2 using the definition of definite integrals as limit of Riemann sum. Okay, let's look at the solution to this question. Step 1, let's get the width, theta x, which has the formula b minus a over n. So b is the upper limit, that's a 2 minus a is the lower limit. And the next one is the grid points, which is this. It has the formula a plus k theta x. My a is 0, so I have this plus. My theta x is this. X can get this to be equal to f of, we have the value of this, that's a 2k over n. Then we have this one as 2 over n. And we have the formula to sigma from k equal to 1 to n of this. So let's plug in that. And that will be equal to, don't forget your function is 2x plus 1. So f of this. So you are substituting this onto your function. And that will be equal to sigma from k equal to 1 to n. Don't forget it's the functions of k. So anything that is not k, we brought outside the function. So we are going to have this one times this one outside. We can take this one outside. So that will be 2 over n. And then we have what? F of what? We have an expression for this one, which is 2k over n. Okay, so let's substitute that. So we have this. So anywhere you see x, you place this one there. 4k over n plus 1. So we substitute this into the function. So we have that. And this will be from k equals to 1 to n. We can, since our function is can leave this k here, that will be 4 over n into bracket k. So we have this. We can break this one. Okay, let's have the k alone. Since the function of k, we are substituting for k. So anything that is not k, you can separate it. You can bring it outside. So that's what we have for this case, which is equal to 2 over n sigma k equal to 1, k equal to 1 to n. 4, I'll take this one outside. Okay, and then plus k equal to 1 to n of 1. So more better way. Then this one, sigma, the summation from k equal to 1 to n of this one is equal to what? Is equal to this over 2. So that's that. And this one, the sigma of 1 from k equal to 1 to n, that's equal to what? That's equal to n. So that's what we have. So, and that will be equal to 4 over n. We have a value for sigma of k, which is what? Which is times n to bracket n plus 1 over 2, and then plus n. So that's what we have there. So this one we cancel. So 2 here, 2. So we have this. So, and that will be equal to 2 into bracket, this n comes in. So we have this, and this one times this one, just the n. And that'll be what? That'll be 1. The 2 is still outside. So on the final note, we have integral of our question, limits as x tends to infinity. What do we have there? Sigma from k equal to 1 to n of f of this. Okay, and already we've gotten value for this. That will be equal to limits as n tends to infinity. Put the value there. Limit as n tends to infinity, 2 into brackets. This will be n over n. That's 1 plus 1 over n. Okay, and then plus what? Plus 1. And you can do your direct substitution, and that will be this one, 1 over infinity, that's 0. So that's gone. So we have 2 into bracket 2 times 1, that's 2, and then plus what? Plus 1. And that will give us what? That's 6. And that's the answer for the Riemann sum. At this point, if you're new, if you're watching me for the first time, please, there's a watermark on the video. Click on it and subscribe. Click on the like button and don't stop there. Please type your comments. I'll respond to your question as soon as possible. Thank you for doing that. Finally, share the links of this video on all your social media platforms.